Hey everybody, it's Mike and Sean again with the Good Math Guys. Today we have another bonus video in our multiplication unit called Halving and Doubling. Truth be told, I had no idea this method even existed until a couple days ago when my dad showed me, so be prepared to have your minds blown if you haven't already seen this, because it's something that's just totally awesome. This particular video, it's not super necessary for you to watch our previous videos in this unit, but we highly suggest that you watch those ones first. Those are your more traditional methods for multiplication. This one's just a little bonus one for those of you that are interested. That being said, I also highly suggest that you watch this video a couple times before trying any of them on your own. And as always, practice, practice, practice. You're not going to get this kind of stuff without practicing. And if you would, please, don't be afraid to comment in the comment section underneath the video. We promise to get back to you guys as soon as we can. That being said, let's get to it.
Hi everybody, Good Math Guys, Mike and Sean back at you again. Now that we've completed our multi-digit multiplication support videos, we don't stop here. The following bonus videos highlight additional solution paths that our students have found useful in their arsenal of how-tos for multiplication. Remember, our goal is to arm students with a variety of strategies that allow them to make decisions regarding the most convenient way for them to proceed. That being said, let's explore a process called halving and doubling. Halving, cut something in half, and doubling. Now, one thing students need to remember here, if they're halving and doubling a multiplication problem, is that at least one of the factors, either the multiplier or the multiplicand, has to be an even number. They can both be even, but at least one of them has to be an even number. Consider this, for example. Let's say we're doing 45 times 6. Here we have an odd multiplicand and an even multiplier. So what we're going to do is double the multiplicand to 90, and we'll have the multiplier to 3. And what we're saying here is that 45 times 6 is going to yield the same product as 90 times 3. And in this case, all we have to do is multiply the 3 times the 9, get 27, and add the 0. So 45 times 6 would be 270. Let's consider another model. How about 125 times 12? In this case, again, the multiplicand 125 is odd, the multiplier is even, so we can double the multiplicand and cut in half the multiplier. So 125 doubles to 250. The 12 halves to a 6. Being that this might be a little bit too difficult for garden variety students to do, let's do this again. Let's have the 6 to a 3, and let's double the 250 to 500. You can see now that we have a much easier problem to do as we multiply 3 times 5 is 15, and this time add 2 zeros. Therefore, 125 times 12 is 1,500. Much, much easier when we have and double. Let's try another one. How about 17 times 4? Again, double the odd number. 17 doubles to 34. And halve the even number. 4 cut in half is 2. 34 times 2. Some kids can do that. Is double 34s would be 68. But if someone's not able to do that, let's continue the doubling and halving process. We'll double the 34 to 68, and we'll have the 2 to 1. And there's identity property. 68 times 1 is equal to 68. Therefore, 17 times 4 is 68. So depending on the level of student trying this, we could have gone with times 2 is the same thing as adding doubles. 34 doubled would be 68. It's up to the kids as to what they find the easiest proposition there. Let's try one more, and then we'll let you, we'll free you guys up to try some on your own. Just make sure that at least one of those factors, either the multiplier or the multiplicand, is an even number. How about 68 times 5? This time what we're going to do is have the multiplicand. So half of 68, 68's an even number, is 34. And what we'll do is double the 5 to a 10. 10 times 34, very easy, it's 340. 1 times 34 is 34, and add the 0. Again, very, very easy. It's not for everybody. Different levels, as we saw here in this particular example. It's what's easy for the kids, and the most important thing here is that they're able to make decisions in terms of what particular way to solve a problem is easiest for them. That being said, there's no more on this program. It's Mike and Sean saying, until next time, bye-bye.